here the y value, as you can see, is I will create another point, the same code as bugs. I will put the y value as I put it before 0.2, so I will put here also 0.2. But as it come down, so it's the minus sign like this. So now I will make another side, and then I will put a link between on this side and this side, so it will connect it. Now for the left side, the same process. I will repeat the same as I did in the right side. So let's create it. Now I will create a point here. I will code it as box, or you can write it as working space like 0.5 cm, and the reference point is 0.5. And now, so this point for the working space. From here we will add daylight. Okay. Now I will drag this one, so we will have space for creating another point. The same I will repeat for the left side. I will creating the point same like I have created on the right side. So the same height of the toe wall I put it on the right side, I will put on the left side. And after that we will put parameter to control the dimensions. The same code I'm using for both the left side and right side. Again, delta x and angle. The length will be same, but the angle will be different because this angle rotated on the right side, so it will be 45. Now for the parapet wall, it's 20 cm. Each of them I have made 20 cm. So here also I will make 20 cm. And now, as you can see, we will put a link between 22 point number 22 and point number 12. And as it is connected, Now for the working space on the left side, I will create another point. So now the subassembly almost completed. So for the datum line, as we discussed already, you must put the datum code so that the civil 3D, the datum surface will follow this line. So I will put for each of the datum line a datum code. So now all the code for the datum line completed. So as you can see here, as you can see the road passing here. So for these two, I make the point from the center. Now I will save this subassembly. The name should be subassembly should be without space, and the description you can write anything. Now to control the geometry, I will create parameter for the width from the center line on the both side. I will create half width from center line. The same value I will put here, and then to show in the civil 3D, I will write distance from center line. You can write anything, so you will understand where you will import this subassembly in civil 3D. Just copy this code and paste in the value in place of value where you put it here. So as I change the value from here, you can see the board from the left side and right side is changing. Okay. For the towel, the height may be changed, so I will put parameter for the towel. You must check your subassembly. So anywhere, as you can see, if you fail, there must be change in other box Culvert. Maybe it can change from 2 to 3 span like this. So you must put input parameter for that one, so that you can control for the parameter if the parameter of the box Culvert change. If both the toe walls are the same depth, the height you must put the same parameter. If different, you must put for the upstream and downstream two different heights. Now as you can see, I change the value as changing. For the outer wall, also I will create parameter. Wall out, I will write here, and the same I will write here to wall height outer. When I put here outer, for the next one I must put inner. So in the civil 3D, when I will open there, I will understand which one is part. copy now this code to the value place, and as I put this one, you can see it's changed accordingly. So I will put the value here 0.9, and it will go to its original height what I put it already. Okay. The next part, the working space, it may be changed. It could be changed from 0.5 to 0.3 like this one. So you must put a parameter for both sides of the working space. Copy value and paste in the where you put the value here in the geometry parameter. Okay. Now if your value changes here, you can control from here like this one. For the angle, you can also create, but the angle are different, so you must create two different parameter for both the side. Now you can create shape for this one if you want, but not it's don't need because it's not composed of concrete all the structure. So let's save this drawing before we have box culvert for method 1. This I will save on method 2, and then we will import this to Civil 3D to check if it is working there or not. Okay, now I'm just creating some assemblies, the assemblies for this one. In the last video, we will apply this shapes, this assembly in cross section, so we will check if it is working or not. So I will click on the custom, right click, import the same process, and the method 2 I will copy here. And now as it will come here, when I click here, the parameter, I put it there, you can see it's appear here. Click here, as you can see the shape same, exactly the same shape appear here, what we created inside the assembly composer. You can create from here, you can control the parameter, the working space. Suppose distance from center line is changing, I can control here. So this was the advantages of the parameter we put here. So to apply in the cross section, I will copy the side slope on the both the side. So like this, you can create the section for box culvert, and then according to your length, you can use in the cross section to calculate the volume of excavation. Like this one, the longitudinal, the cross section we have already made in the method number